Subscribe to this YouTube channel by clicking the subscription button below. For future webinars and online short courses, please visit our website at australianwaterschool.com.au. Welcome to the 73rd Australian Water School webinar brought to you by IceWarm, and we're delighted you can join us today to discuss this critical topic of groundwater modelling with Modflow. It'll be presented by Konrad Mierlinski and Wolfgang Schmidt, and they are two of the best in the business of groundwater modelling, and it's going to be a good 1 hour session. I'm absolutely certain of that. My name's Trevor Pillar. I'm the National Partnerships Manager here at IceWarm and the webinar chair. But it's all about you. Once again, this webinar has attracted a huge global spread. You can see on the screens there now. Attendees from across the world. Just a really fantastic spread. Thank you, everyone, for joining us. Well, I think we can get right into this. And thank you, Conrad. Thank you, Wolfgang, from wherever you are. Well, I know where you are. Conrad, welcome. Your microphones are not on. Both here. Thank you. Where are you from, Conrad? This morning, this evening, this afternoon?
Hi, Trevor. I'm originally from Poland, but I'm currently based in Brazil. I used to live in Australia too for well, basically 6 years in CSIRO, and
Fantastic.
Currently I live in Brazil.
Yep, and burning the midnight oil, I understand.
Wow, it's actually not that bad. Now it's about 9:30 p.m., so it's not very late. I could see that some participants from the middle part of that map you showed, they must probably be in a much more inconvenient situation than I am here.
That's for sure. Probably that's the case for Wolfgang over there. You're in Western Australia. Wolfgang, your microphone is not on. There it is. Yeah.
Yeah, I'm in Western Australia, and obviously with a name like this, it can only be a German name. So that's where I'm originally from. But I have come across the world in many parts of where we have participants from. So I've been in the Middle East, so Sabah al-Khair to you, and then United States, hello there, and obviously in Europe, bonjour, and my wife is Filipino, so Makatang Umaga, whoever is from over there.
Well done. Yes, no, that's fantastic. It's great to have presenters who understand the breadth of our attendees at the webinar today. Where are you presenting? So what is your motivation, and driver, Conrad, for doing this work?
Well, probably there are a few elements here, but I think that the most important, Trevor, is that we want to see our models to be more impactful.
Right.
And in order to achieve this, we need to firstly support professionals to make sure that the models are good enough. And secondly, we also need to convey our message to decision makers to make sure that they feel comfortable to adapt the decisions that are coming from modeling.
Yep.
So this would be basically the most important thing. Probably there are a few others, but this is the most important motivation to give this kind of webinar. But it's excellent to be with you guys here also. This is my first webinar I'm giving.
Yep.
So it's excellent experience, and I'm really happy with the crowd that is spread around the world. There is probably more than 100 participants, and that's great. This is my great pleasure to be here.
Yep. You've certainly gone beyond that now, but thank you for that. Yes, and yourself, Wolfgang, what motivates you into this sort of work?
Well, I've been in this kind of business for a long time, probably 20 plus years, and for a long time, Modflow was just Modflow. So my motivation is really to educate the public a little bit about the fact that Modflow is really not Modflow anymore.
No.
Modflow is at a crossroads, and we're basically branching out in this class into different types of Modflows, one in the direction of more integrated hydrologic models, and the other one in the area of having multiple models presented in one simulation or more heterogeneous aquifer conditions. So all of those things have huge impact for management and in the times of global climate change.
Fantastic. That brings a huge amount of experience to it, and you put your finger on a emerging issue. Modflow is no longer Modflow. Fantastic beginning. This I haven't done a formal introduction. Can I just do that for a minute, Christy? If you want to put that the screen back up again, we just wanted to see the background for both yourselves from different parts of the modelling experience. So Conrad's 15 years research and consulting experience across Europe, Australia and South America, and has been an instructor in a variety of modelling courses for 7 years. And Wolfgang with CSIRO is a researcher with 20 years Modflow experience and original author of the farm process for Modflow, now integrated into the US Geological Society's Modflow-OWHM. So there's a large amount of experience being brought to bear in this webinar today. And I just wanted to highlight that you'll be hearing from the best of the best. And we just encourage you to get your questions and discussion issues up on the Q&A board or come on screen. Both would be great. But by all means, get them in early, get them in often, and let's have a good discussion over this next 60 minutes. But for now, I'm going to hand over to Conrad, and you're just going to pass it between you and Wolfgang, Conrad, and I'll leave that to you. And any relevant questions that come up as we go through, I'll break in at the right moments. So over to you, Conrad.
Thank you, Trevor. So we would like to start this webinar giving a little bit of introduction about what the model is, what we can expect from modeling, why do we really bother about modeling. Then we would like to present you guys a little bit of to show a little bit more about Modflow, how it does the computation, but without going in too much into details. Then we would like to present to you 2 examples. We have some suggestions when it for the courses that we would like to share with you. There are some interesting references, and finally we'll provide you with our contact details. So firstly, the aim of this webinar is basically to introduce groundwater modeling concepts to iceworm community and to present widely used Modflow versions and basically their capabilities. You will find that the capabilities differ quite significantly. And finally, we'll share our experience with modeling. So, what is a model? It's basically a simplified version of a real system and phenomena that takes place within this, which approximately simulates the system's excitation response relationship that are of interest. And this is very broad definition. When we talk about groundwater modeling, we normally think about mathematical model, numerical model, but obviously there may be also analytical models. And this particular situation, we'll be talking about deterministic groundwater models. So it means that we think about a model that is solved with a computer in a deterministic way, and it applies to groundwater flow, solute transport, water quality phenomena, etc. So it applies to the groundwater, to a specific groundwater problem. And the objectives may be as follows. Firstly, to obtain a better understanding of a system from a geological, hydrological, and chemical point of view. For example, we may want to estimate groundwater resources, or we may to understand spreading of contaminant, or we may study infiltration and processes of clogging during managed aquifer recharge. Secondly, we use models to predict the behavior of a system, of groundwater system, in response to excitations that stem from the implementation of management decisions. We use them to provide information required in order to comply with regulations. And finally, to get information for the design of a monitoring network or field experiments by predicting systems' future behavior. And there is a workflow for hydrogeological modeling. There is a number of steps involved. Everything basically comes from the top, that is what is really needed, what's the motivation of the modeling, or what's the objective. And then there is obviously, we need for modeling, any kind of modeling, we need data, quality data, and then we develop a model. We start developing model. Firstly, starting with a conceptual model, which I explain a little bit what it is about, and then developing mathematical models. In this case, it's very broad, actually, workflow. In this case, it's saying that we develop mathematical models, but obviously, if some codes are available for us, and we don't well, we have to develop them, but some of the elements that are shown in this particular workflow, we basically don't do. We use the ready solutions. This could be, for example, the next element, which is selection of a solution, method, and code. And then we, as modelers, we run simulations to predict a certain scenario, and there is a number of other elements involved, and you can see that there is some looping here. After predictive model simulations, we may need to probably calibrate and validate the model, but it's very likely that we may need some more data, or we need to verify our conceptual model. Almost any time we need to do some kind of sensitivity analysis and analysis of uncertainty, particularly when we talk about the predictions. And then we finally give the answer. This webinar is basically focused on 3 steps, so we'll not be talking about quality of field data or how to perform uncertainty analysis, but what's conceptual model, why we select certain code, and what those codes offer. And when talking about examples, we may talk a little bit about predictive model simulations. So here in this quite complex slide, we have 2 examples of conceptual models. On the left-hand side, we can see a model of a multi-layered system. It's basically on the upper part we have hydrogeological cross-section. So this is the cross-section we normally have to have in mind if we this kind of image we need to have in mind when we do modeling. So we have 7 aquifers, and they have certain connections, or they may not have any connections. But in the lower part of this plot, we can see how these layers, or how this hydrogeological information is represented in a conceptual way, and how certain layers may be connected with respect to each other, but also with respect to the surrounding, which in this case, on the left-hand side, we can see, we can see that there are some connections with a river system, or it can be connection with atmosphere. And so the aquifer is in this particular location. This aquifer is unconfined aquifer and may receive recharge from precipitation. And on the right-hand side, there is another way of representing conceptual model. It's a 3D diagram, and a number of processes is shown here. We have basically two aquifer system. The upper aquifer, unconfined aquifer, has strong interactions with surface water, receives recharge, but it's also not only from precipitation but also from irrigation. It's drained. There is a river. There is a pumping well. And you could also see that there is some connection, probably not, well, from this we can't really see much, but there is some connection with the lower aquifer, which is confined aquifer. And then we may looking at this picture, we may always think where possible connections may be, or where percolation, where the percolation takes place, exchange between aquifers, and so on, So this is the conceptual model, and this slide shows you how we translate the conceptual model into numerical model. We have an image. We need to have an image of the system we model. Obviously, this is very simple scenario. Two-dimensional aquifer looking from a top plan view, and on the right-hand side, this conceptual model is already divided or subdivided into smaller elements. We call them, we call it grid, and for each element has specific calculation is taking place for each single element, and they are connected with respect to each other. They may have a bit different function, and I will also talk about this a little bit more. And so at this stage, when we talk about selection of the code or program, we would like to show you why people normally, or would like to discuss with you why people normally choose Modflow for modeling. I particularly started also with Modflow many years ago in Poland, and I found it at that time quite easy software to learn. But there are also different motivations, and they are as follows. This is a public domain and open source, so you can, using certain tools, you can basically use models, develop models for free. Obviously, there are some commercial. There is some commercial software on the market available, and which may help you to develop models, but it doesn't have to be. And Modflow is very widely used, and it's legally tested. It has very convenient modular program structure, which means that certain hydrologic capabilities are grouped together, and which may be invoked, and they can be invoked independently or of each other. New packages can be also added without the necessity of changing the existing packages. So this is something, once you get familiar with these concepts, then the workflow is quite easy. Modflow is also used because it also serves as a basis for other studies. For example, together with different software, it can be used to study contamination problems, or water quality problems, or density-dependent flow, and so forth. And sometimes it's also used because there is a requirement of a client or a regulator. Obviously, well, personally, I'm not very much in favor of this kind of requirement, because I believe that a modeler should be capable of influencing what kind of choices are made. Modeling choices, including choices of the code, are made depending on the objective of the modeling, but in practice, this is often also the case. So what Modflow does is basically it solves a distribution of hydraulic heads in space and time using groundwater flow equation. This groundwater flow equation that you see on the screen is basically combines Darcy's law and mass conservation law, and it's this three-dimensional equation. So we have three space variables, x, y, z. There is time variable if we run models in transient mode, and there are certain parameters, basically hydraulic conductivity of the aquifer material, but also specific storage. And we also have very important term that is shown here as W, and this term combines all sources and sinks in the model, because this model is not isolated. It's there is always some kind of, almost always, some kind of isolation. There are very few groundwater systems in the world we know that would be completely isolated from the surrounding. So the W term is responsible for this. And then there are many ways of solving numerical this equation, basically. And in Modflow, it's basically it's either finite difference solution or control volume finite difference solution that started back in 2013 with Modflow-USG and continues now with Modflow 6. On the right-hand side, you have a picture that is showing finite difference scheme used in Modflow 2005. It's, as you can see, it's very regular grid, and so for if every single element of this or cell, we call it cell, and we calculate, we may get we can calculate hydraulic head. And you can also see that every single element is surrounded by minimum 3 other elements or maximum 6 elements. If they are, particularly if they are somewhere inside this big cube. Just trying to wrap it up, it's we have input data, and this is the data we gathered from the field study. Sometimes literature surveys and so on. This includes hydraulic conductivities so aquifer properties, hydraulic conductivity, and specific storage. And then we have these sources and sinks, the W term in the equation, and they are controlled by boundary conditions. We assign boundary conditions in specific locations of the model, basically where there are contacts of a model or of a system with the surroundings. And as a result, the Modflow solves the equation, and it gives us a hydraulic head distribution, which we which can actually, from hydraulic head distribution, then the balances or the water budget is calculated. Also velocities. Velocities may be important, particularly if we want to know, we want to use them for solid transport simulations. and a couple of other things like base flows or capture processes. The boundary conditions, the examples you can see. So this is where this is how the water is exchanged between the groundwater system and the surrounding. And groundwater system may receive water, and the example would be recharge from precipitation when water. So this is the input of water to the system. If we have a pumping well, then it works in a very similar way. The water goes back to it's removed from the system. Aquifer and a stream or aquifer surface water interaction are quite complicated, and they can be treated in different ways. And we may also have another example is an open pit or closed mine. Also, it's also an example of boundary condition, because there is water there, and obviously a pit is rarely it's normally very strongly connected with the groundwater body, particularly if there is discharge and the drainage of the pit happening. So there is stronger inflow to the pit, and water and groundwater system is getting depleted with water. From a this basically the mathematical representation of the boundary conditions, and there are three major kinds of boundary conditions. The first one, we call it first kind boundary condition. This is where there is a head specified, a number of or the height of water. Then we may have a second kind of boundary condition where we specify flux of water. And thirdly, we have a Cauchy boundary condition, which is combination of both. And on the right-hand side, you may see the example where there is a river, conceptual model of a river shown, and a river is surrounded by the groundwater system, and head in a cell next to the river is higher than inside the river, which means that there will be flow, the river will be receiving water from the groundwater system, and the flux or the amount of water that the river receives depends on the head difference, but also on the permeability of the stream bed material. And this equation basically on the left side, it shows this kind of situation. And so with this classical Modflow, we call it Modflow 2005, we basically have a certain structure that a working structure. What we have is a number of packages, or this is basically a number of text files that are in certain in folder or in directory on your computer, and each file contains certain information. So, for example, we have basic package. We may have discretization package that keeps information about spatial and temporal discretization, so the spacing between the cells. We may have information about the aquifer properties, and there is a number of other packages that are responsible for this exchange of water with the surrounding dimensions. So it's basically the boundary conditions. We have first kind boundary condition in the first group. Then we have second kind of boundary condition and third kind. And you have a list of them. Some of them quite specific. Stream flow routing package or evaporation packages, subsidence. As you can see here, it basically shows you what kind of processes can easily be modeled with Modflow, and obviously in further reading tell you whether this would be appropriate in a certain situation you may be interested. And at this moment, I would like to pass to Wolfgang, who will be talking about Modflow-OWHM. But I will come back a bit later.
Would this be a good spot to just take a couple of these questions? They're coming in on the Q&A board. You might notice there, Wolfgang and Conrad. Are you okay if we just take a couple of these questions now? We won't take them all, but we'll maybe just a couple of them. Just keep the discussion going. Well, look, Suzanne McDonald is a water treatment technologist in GWM water in Australia, new to modelling. Her question was pretty broad and pretty open. Is Modflow the best package? Is there a good course you could recommend to get me started? Yeah.
Well,
we do have a good course.
A very, very good question. Well, basically, Susan, it's definitely a very robust package, but everything depends on the scenarios you may have, the objective of your modeling. I believe there is no package or no software in groundwater market available that can be called that, oh, this is the best. Everything depends what you are looking at. For example, if you are interested in hydraulic fracturing or multi-phase flow, probably Modflow is not the best choice. But if you want to calculate groundwater or estimate groundwater resources in Great Artesian Basin, Modflow would be definitely one of the softwares you should consider. And is there a good course? Well, it's we will be talking a little bit about this later. And we will show you something in a few minutes. Maybe let's keep it for later then.
Sure. Yeah, we do have 3 online courses coming up in October, December, and February by Conrad and Wolfgang. We'll talk more about that later, as Conrad says. Any comments, Wolfgang, on that question?
No, that's
okay. So we'll move on. Thanks, Suzanne, for your question. One more question then from Tahira, a senior engineer in Canada. What type of input data is required to run the model in Modflow? What's the basic data platform, common source of data? That's that second question.
Well, it's the input data I mentioned just a few minutes ago. It's what we really need from the mathematical point of view. We need hydraulic conductivity, specific storage, and we need fluxes to the system. Is there any platform that provides you this data? Probably there is no. It also depends where you work, and from my perspective, I always I work in different parts of the world, and I'm getting data. Firstly, I'm asking person who wants me to develop a model, and I will ask him what kind of data is available and whether they can recommend any sources of data. And if they don't know, obviously I have to look by myself. But there is no one platform that may have everything, all data available that you can run a model for. Again, it depends what kind of objective you may have, because we may also run a model without much data. Obviously, this will be a model that is quite uncertain, or the results may be not very certain. And sometimes we have to work in very in areas with very little information, and we also have to do something. So yeah, so this is basically it. What I would probably could say about this.
And does one just additional question from Tahira is it capable, Modflow capable to calculate groundwater quantity and groundwater quality as well?
The answer is no. The answer is no, because you need another code for that, which is called MT3D.
HT.
MT3D.
MT3D
yes,
code.
Right.
Yeah, for quality, yes. So it's they work together. So Modflow, what Modflow does, it calculates heads and basically velocities, and another software uses velocities calculated by Modflow and does the calculation of solid transport that includes advection, dispersion, and well, basically advection and dispersion, but also diffusion.
Yep. Okay. We might leave the questions there. Thanks so much. There's more questions coming. We'll come back to those questions again. Stay online there, Sunita, Priscilla, Sid, Nathan, Adonis. I can see your questions coming in. That's fantastic. But we'll move straight across to Wolfgang now. We're going to have to keep our questions, our answers, sorry, Wolfgang, Conrad, to keep them short because there's a lot more coming through as we go, and there's a lot more material that we're going to be presenting. Thanks both of you so much. But I would say to everybody, go on the website, LinkedIn, Facebook, Twitter, and you'll see the online courses coming up for beginners in Modflow and groundwater modelling. There'll be 3 courses coming up in October, December, and February across the next 6 months. We'll be presenting, both Conrad and Wolfgang presenting that. All right, well, let's press right on. Over to you, Wolfgang. Might have to come a little closer to the mic. We can hear you okay, but
okay.
just a bit
Let me
clearer.
just ask you,
A little bit echoey, that's all.
Are you seeing the presentation that I'm running off?
We can. Yep, perfectly. Thank you. Yes.
So you see this one, that I'm changing this slide? Is that the presentation?
All clear. Yep.
Okay. So in addition to what Conrad was saying about Modflow 2005, obviously there are different versions of Modflow out there now. Hang on, I just need to see you guys. Move that over here. All right, thanks. So the main difference between Modflow 2005 and Modflow one-water hydrologic model is that Modflow one-water hydrologic model is a more advanced version, which you only want to use if you're really interested in management questions and water demand and supply questions. And it can do everything that Modflow 2005 can do as well, and it's based on the farm process. So what that means is the farm process actually drives the demand calculations and the supply constraint or the constrained supplies. And so basically these 3, if you can see my mouse moving, so these 3 points actually belong together. So in other words, it calculates the actual ET, which is contrary to what Modflow normally does. All that Modflow normally does is ET from groundwater. So it simulates the entirety of ET and the resulting irrigation demand that you can back out from it, and then subsequently surface water and groundwater deliveries, and runoff and recharge are byproducts. Now you remember what Conrad said about, for example, recharge. That's a specified boundary condition normally, but in this case recharge becomes a simulated parameter. So in other words, this is a model output, just like hydraulic heads or velocities. So in other words, if you drive the system with demand and constrained supplies, you're going to have a lot more simulated parameters. That is pretty good to simulate those because they are highly uncertain. So those are parameters that later on you would like to run uncertainty analysis on. The next difference is that normally you have, like Conrad said, you have non-head dependent and head dependent boundary conditions. In this case, a lot of the processes from one package depend on the other package's flow, meaning it's flow dependent. And then we also feedback the land subsidence deformation on the land surface and the layer tops and bottoms into how that affects the flows of each package. So that's another difference. And lastly, the next difference is that Modflow-OWHM can calculate the groundwater budgets just like Modflow 2005 can. But in order to have to simulate the let me see, this doesn't work here yet. To simulate all water in the hydrologic cycle, we also have landscape water budgets. We used to call it just farm budgets, but actually for larger entities like irrigation districts or water accounting areas, we like to call them now landscape water budgets. And lastly, as I said before, it calculates economic budgets, so demand and supply. Now, Modflow-OWHM basically also fuses a lot of standalone versions into one integrated hydrologic flow model. So it needs to be understood that there were a few years ago, just a few years ago still, a lot of successors of Modflow 2005 that had a specialty that stood alone, like local grid refinement, the surface water routing process, conduit flow process, the Newton-Raphson solver for mainly unconfined conditions with a dry wetting problem, and the unstructured grid, and the farm process that I was involved in. Now, Modflow-OWHM fuses a lot of those together, and later on we will talk about Modflow-6 that also fuses some capabilities of some of those packages together. So this is why I said at the beginning, Modflow isn't Modflow anymore. So people really need to know what they want. They can use each of those standalone versions as well, or they can use Modflow-OWHM if it suits their application, or they can use Modflow-6. So it really depends on what you want. Now, in Modflow-OWHM, based on the farm process, you can simulate all the transpiration and evaporation from native and riparian vegetation, a natural artificial recharge, and then you need to know which demand you would like to calculate. So either you have the demand of dryland agriculture, or of aquifer storage and recovery systems, or of irrigation systems. So these are all demand units. And then you basically supply them with known water quantities, say, for example, imported water pipelines that we call non-routed deliveries, or routed surface water deliveries, or groundwater pumpage. Now, the in excess of precipitation and irrigation in excess of the crop water demand will then be runoff and delayed recharge. And if it's hooked up with unsaturated zone flow, then it may even be delayed. Now, in this slide, I won't go through everything here, that way will take much too long, but this is for people who are more interested in Modflow-OWHM. But they are just as an example. You can see here that the streams, the delivery from the streams is hooked up with the conjunctive use of the farm process, or pumping, the supplemental groundwater pumping is hooked up, for example, with the multi-node well package. So you basically pass on your demand onto the streams and divert automatically, or the residual requirements onto the multi-node well package, where otherwise you would have to hardwire a desired pumpage. Likewise, the return flows are either inefficient losses to runoff and back into the river, or they are going into the unsaturated zone flow package in order to calculate delayed recharge. This is why we call it one water hydrologic model, because it simulates all the water of the hydrologic cycle at all times. Now, this slide I just put in this morning, this I just want to have for the record. So if somebody's interested in obtaining Modflow-OWHM, these are the internet links that you can get it from. And just the last comment, so Scott Boyce right now is in the driving seat of developing OWHM version 2, and that should come out within the next few weeks or months. And that is basically all from me for now. So probably back to you, Conrad. Now the next slides will be Modflow-6.
Yep.
And then you can take my presentation away.
Yeah, I've already done this.
Conrad, would you mind if we took a couple more of these questions, just briefly?
Yeah, sure. No, not a problem.
All right. Nathan Young is a senior water. No, he's not. He's not. Not him here. A senior staff at Schnabel Engineering in the US. And he said, is it typically recommended to calibrate a steady state groundwater model before running and calibrating the transient scenario? That's the first question on your Q&A list at the bottom there.
Yeah, short answer would be yes.
That's one he wants to hear. That's good. Maybe we'll leave short answers for now. Is that okay, or is there something you'd like to say extra?
Yeah, I mean, the short answer is yes, but a lot of times nowadays when you deal with uncertainty analysis, you actually bypass the calibration part because you're dealing with the depth and breadth of the uncertainty that can happen. So, but this is a very different topic. So in this class, I don't think we go into, like Conrad said at the beginning, remember these 3 blue boxes? So the question of calibration and uncertainty is outside of the topic of this class.
Yep. So this webinar is fairly brief, but do come to the short courses, Nathan. That would be more detail will be provided there for sure. Sunita is from Rockhampton, Australia, senior environmental scientist with EcoSure in Australia, has said, can Modflow be used to model groundwater surface water connectivity?
Yes, absolutely. As you can see, especially with Modflow-OWHM hydrologic model, the interaction between surface water and groundwater is absolutely a given now. And I'm talking both about the landscape groundwater interaction as well as the stream aquifer interaction. I would like to be quite specific about this because a lot of times people confuse the two. They talk about surface water groundwater interaction. In many cases, it just means stream aquifer interaction. And there are different tools out there. Yeah. So as you can see with Modflow-OWHM, it's more about having surface water groundwater interaction in the sense also that you have surface water and groundwater conjunctive use to satisfy your demand. But for example, if you want riverbank infiltration and two-dimensional flooding, there are tools out there that go beyond what Conrad is talking about. Like in addition to the streamflow routing package, there is the surface water routing package out there, which actually can simulate the sentence equation. So it actually simulates really a wave of flow in 2 dimensions. And that is all done in Modflow. So that's why I said at the beginning, Modflow isn't really Modflow anymore. And no. it goes way beyond groundwater modeling.
Yep. Sid's a mining engineer with Energy Australia. How can we import 3D geological model layers in DXF and DWG format into Modflow?
Yeah,
wow. Yeah. Well, there are definitely to do this, you need a graphical user interface where you import specific information into model. There is a number of commercial interfaces that can do this very easily. In open software, you can also do this, particularly using some tools like FlowPy. I'm actually not sure about these specific files, whether you can use ModelMuse, but ModelMuse has also some importing capabilities. So we would have to check whether these particular files can be imported into ModelMuse.
Any comments, Wolfgang, on that? No comments from yourself, Wolfgang, on that?
No,
that's all right. Okay. No, all right. Thank you, Conrad. I'm keeping these responses short. Sorry, gentlemen, because there's many more to come. Maybe we'll stop there for a minute, and we have 10 minutes toward the end of the hour for our webinar. We might be going a few minutes just beyond the hour, but let's keep it as brief as possible. But I would recommend to everybody that you sign up, register for these online courses. Though they will get to some of the issues here. Over to you then, Conrad.
Thanks. Let me close this. Oops. Sorry. Now we would like to. I would like to tell a few words about Modflow 6. Modflow 6 offers you a flexible geometry. So it's not, well, it's also, it can be used a regular grid as we showed before, but we can also use unstructured grids. It has some additional features, and they include fully 3-dimensional anisotropy on regular and irregular grids. The computational approach used here can be allows us that numerically the cells don't have to be adjacent one to each other in order to simulate flow between them. So this is something very interesting and in certain circumstances may be very useful. A number of different models can be embedded into a single simulation process. So for example, you can model surface water independent of groundwater model, but they are still under the same umbrella. Then it's due to unstructured grid properties, it's quite efficient with respect to computer memory and execution time. There is probably not, we don't have probably much time to talk in very much detail about this, but I would like to show you a little bit more about the discretization. So in a horizontal, if you look at the plan view, we in a classical Modflow 2005, you can see if you have your area of interest, what you normally needed to do in the past, you still in the Modflow 2005, you have to extend, if you want to refine this area of interest, this refinement goes across the whole model domain. And in Modflow 6, this is one of the ways to refine the area of interest. So by doing this, you have much smaller number of computational cells, and this saves you. There is some computational efficiency gained. And then in vertical direction, we also gain a little bit more, because in classical Modflow 2005 or Modflow-OWHM, what you need to do, if you have layers that are discontinuous, geological layers that are discontinuous, you may still have you still need to in order to represent them, you need to put a layer inside, and obviously, well, this layer may have properties of the surrounding layers. So from a conceptual point of view, this is the same aquifer, but it generates a number of additional layers. In Modflow 6, this is basically excluded. The cell that is that pinch out is excluded from the computational process, so it saves basically time. There is a number of technical features related with Modflow 6, mostly management of dry cell problem, or this is important, but it has been already implemented before in Modflow and WT. Wolfgang mentioned. I will probably not be talking too much about the packages. They are different here. Some of them work in a similar way, but some of them are completely new. Now I would like to mention only about the graphical user interfaces. I mentioned before that there is open source software available. So this is free of charge. You can download this software anytime and use it. FlowPy is very popular at the moment. It's very powerful, and it's interface with Python. So if you have a little bit of programming experience, you would be definitely interested in FlowPy. And I would actually say that everyone who is planning to do modeling on a regular basis should definitely look at this, because it's very powerful tool. ModelMuse is another option that is available and can be downloaded from the USGS website. There is a FreeWatt that is actually graphical user interfaces, and it uses FlowPy too. and there is PM-WIN. I personally started when I started modeling. I used PM-WIN. At this moment, I would probably not recommend this because there is a number of new versions of Modflow and packages, and this will not be, the use of PM-WIN PM-WIN will not be very beneficial. And there is a number of commercial software, just to mention a few of them. It's Groundwater Vistas, Visual Modflow, GMS, no newer version of PM-WIN or Ike Hydro, and there is a number of more. And exporting, well, we had a question about importing and exporting. It's another story, because once your model is done, the files are normally in binary. The output is in binary files, and you need to read in some way. So people either use commercial software like Visual Modflow, and there is a software that USGS software that is used for input, and this is a model viewer, and it actually and this one is public domain software. Now I would like to give you very briefly talk about some one example. Give you one example from the Santa Catarina island where I live at the moment, where we use Modflow in order to study groundwater resources, but basically the risk of seawater intrusion into the aquifer. The aquifer here, it's about 10 kilometers long and 3 kilometers wide, about 50 meters deep or thick. And on the right-hand side, you can see, this is actually Visual Modflow visualization of this 3D visualization of this aquifer. There are some poorly permeable layers there. And what we wanted to know is to see what happens if we pump 30% more that is pumped nowadays. So, and then there was an option to also to see whether some managed aquifer charge scheme could be implemented in order to make sure that there is no seawater intrusion. And so we have done a predictive modeling of the groundwater heads, and you can see the water level maps, and also in 3D view of this under two different scenarios. And then we have done SeaWatt. That's another software for water quality when we have density dependent flow. And we were interested how much, and we could see that if there is pumping without managed aquifer charge, there is a very strong risk of, very big risk of saltwater intrusion that from two sides may enter in the aquifer. And we did a little bit of sensitivity analysis here too. And now I pass again to Wolfgang to talk about his example. Thank you. Wolfgang?
Hi, you there, Wolfgang?
Yep. Yes, I am. I just need to get my,
That's all right.
my presentation started again.
That's okay.
Where is it?
So we are running at the 1 hour mark at the moment. I know we've got a little bit to go through, but if everybody's happy to hold on for a bit longer, we'll go for another 10-15 minutes, I think.
Can you see this?
We've got that now. Yep. Thank you. Yep.
Yeah. Okay. So how much more should we go over? 15 minutes or?
I'm suggesting we do 15 minutes more. People are hanging on to the.
All right. I'll just breeze through all of this a bit quicker. So in terms of Modflow-OWHM examples, most examples of Modflow-OWHM are located in the US Southwest, and one recently in South Africa, and another one in Mexico. So it is being used more and more, but I only can talk here about the poster boy of those models, which is the first one that I was involved in, and that is in the Central Valley. So in the Central Valley, if you remember, what we wanted to do is to, hang on, I can't see you guys, just a minute. How do I do this? Just anyway. So in the Central Valley, we do this demand-based calculations, like in a bank account, for different water accounting units. So not only do we calculate demand based on climate and crop coefficients that are basically obviously land use dependent, but we're doing this for a particular area. That's why it used to be called farm process, because it is for a family farm or for a farm. But a water accounting unit in this case can be anything. It can be a political entity, or it can be an irrigation district. And then you get supplies from rivers and from groundwater pumping. And what we do in this case, because the land use is so diverse, is that you are lumping certain crops together into, say, for example, field crops. So what you do is you're driving the demand of this particular crop, not with a crop coefficient, but with a composite crop coefficient. And then the outcome is obviously this demand and supply budgets that I mentioned before. So these are time series of demand and supply across the whole historic period of this model. And a zoom up here for a particular time period shows you that you have in black the demands, the total delivery requirement, and then in blue you have routed deliveries, and with some time lag then you have the groundwater pumping kicking in. So this is done here for an individual farm or water accounting unit, or water balance subregion as it's called in the Central Valley. But then you also have physical inflows and outflows. So this is the same water balance subregion. So you can see you have components, physical inflows into the landscape, such as evapotranspiration, groundwater uptake, or portions of evapotranspiration that are satisfied by irrigation and precipitation. But then you have outflows such as recharge and runoff. So at this, what I want you to keep in mind is not all the details, but just the point that you have individual demand and supply budgets for water accounting units, and you also have individual landscape budgets. Now, what we do with the entire model once it's calibrated is we're driving it into the future. So the beauty of this is that because it is demand-based, and the demand is based on climate and crop parameters, the inflows and at the streams, at the boundary, and the climate can be pre-processed by downscaled global climate change models. So the way that works is you got a GCM, you downscale it, you populate rainfall runoff models that are surrounding the Modflow model, and then you basically drive the inflows into the rivers and the climate from the downscaled climate models with reference ET, and then you basically can run your Modflow-OWHM model into the future. And remember that this kind of coupling is only possible if you have an automatic link between demand and supply, and the demand is basically driven by climate. Otherwise, in standard Modflow, this kind of coupling wouldn't be possible. So now here is, you remember I told you about these individual budgets, economic budgets and physical budgets. This is now tallied up for the entire Central Valley. So this is the demand and supply for the whole model. That's historic. So in blue, you have surface water deliveries that are basically satisfying the demand, and then you have groundwater deliveries. So you see in the 80s, there was a bit of a relief, and the surface water deliveries here, they made up for a lot of the demand. So actually the aquifers were able to recover, and groundwater pumpage was down. But with the GCM predictions, with wet and dry periods, and obviously the dry periods getting longer and longer, the future looks pretty dire, judging from this model. So you get an extensive increase in demand, and following that, obviously a quite increasing increase in surface water deliveries and also groundwater pumping. So now the last slide I want to show for this example is that once you have this dynamic linkage between climate, demand and supply in Modflow, you can also drive with those parameters other simulation parameters, such as land subsidence. So in other words, land subsidence in this case is also calculated into the future, driven by climate and supply and demand. And this is just what you can see with a normal business as usual scenario. And this is basically with a 4% annual growth. So this is the Central Valley model. And if you're interested in that, you can just Google for it and download it. And the lead author on this is Claudia Font, so please contact her if you have any questions. And also, of course, this model that I'm showing you, I think the historic period ended in 2006 and the publication date was 2009. So there are newer versions in process at the moment, which should be published shortly. So back over to you, Conrad, now.
Yes, thank you.
So we got about 5-6 minutes, Conrad, about 5 minutes ago.
Yep. So basically, now we would like to suggest some courses. This is something that we still have to, well, the first course is will be in October 2019, in the beginning of October, and this would be Introduction to Groundwater Modeling with Modflow. And at this point, we suggest to use Modflow 2005 together with ModelMuse, which is open source software. So if you want to, you basically if you want to continue and develop some models with it, you don't need to invest any money into the software. Everything is publicly available. Second will be Modflow-OWHM with FreeWatt, and third will be some kind of comparison of approaches when developing a groundwater model. So we'll be talking about Modflow 2005, Modflow-OWHM, and Modflow-6. So the first course will be very basic, as I mentioned, basically how to import data, develop model, run, and extract results, evaluate some different conceptual scenarios, and maybe delineate areas contributing to recharge. This is some kind of conceptual problem we may be working on, and well, this will be very basic level. If you are starting modeling, if you are or you had a break and you want to refresh your knowledge about Modflow 2005, this will be a good course for you. Then we have Wolfgang's course. Wolfgang, would you like to say something and probably go to the end with this?
Yes, but we'll use your presentation. So if you just
sure.
So this class basically will just show you the few highlights of Modflow-OWHM embedded in QGIS, which is the freeware GIS platform in FreeMod. So it's all free. It's Modflow-OWHM and it's FreeMod and it's QGIS, and we'll show you how to develop a very simple model, integrated hydrologic model, where we calculate precisely the budgets that you also saw on a larger scale for the Central Valley. If you can go to the next slide, Conrad.
Yep.
So this is basically where you can see the layout. This is the standard farm process example that we have had since probably almost now 15 years. One of the things to mention is it would be really good if participants for this class took Conrad's class first, because you have to have a basic understanding of how to do a general Modflow 2005 model. In the interest of time, because we got two different sessions, 2 by 2 hours, we may actually, I don't know really, I haven't decided on this, but we may import the entire Modflow 2005 model first, and then superimpose the farm process in the second session. So I have to experiment how that works. But what I will do for this class is I will send you all the download instructions and make sure that you have FreeBud properly installed, which is can be quite tricky. But this needs to happen obviously at least a week or two before we start this class. So if you want to sign up for this class, make sure you sign up early, not in the last minute, because you won't be able to install the stuff anymore. And below you see exactly what we want to do with this. So the outcome is demand and supply and inflows and outflows. That is not a lot compared to what all the stuff that Modflow-OWHM can do, but that's all we can do probably in 2 by 2 hours. Konrad?
Yep, and the final, the February, we would like to integrate in some way the approaches and to talk about possibly develop a model, a single model using different kind of tools, and we may include a demonstration also how to use FlowPy. Now, obviously, this is quite a complex thing, so we will not be developing model using FlowPy probably, because at this stage it may be too much. But at least the demonstration, and you can later you can also play around by yourself and see what the capabilities are of FlowPy. But at this stage I can tell you that the capabilities are huge. So it's definitely something that we at some stage would like to share with you guys. And then what we prepared are some references, everything what we have. The figures we showed and some concepts we use. Very important book is the Anderson, 2015. There are a few others too. Bear, obviously, 2010. There are references for Modflow, Harbo, 2005, and a couple of other things, and open source graphic user interfaces too. Thank you very much for your attention. That has been very good time. I'm still replying some of the software, some of these questions here. Trevor, I'm replying some, like on the fly.
I see that.
But I haven't replied everything yet.
No, that's been fantastic.
Yeah, so if what will be, so shall I continue like this? Or?
Certainly. We'll have a minute or two to get going. But Wolfgang, Konrad, it's been absolutely fantastic. Your carefully, step-by-step, precept-on-precept approach, everybody really appreciates. It's been a wonderful hour and a quarter, and much more to come. My colleague Christy has just put up on the chat line, you'll see the registration link. Do go to that. And we'll have a fantastic time in October, December, and February to tease this all out in much more detail. But for now, I just want to say how much we've appreciated your attendance, and for Konrad and Wolfgang, your huge amount of effort and preparation that goes into these things. We greatly appreciate it, and we look forward to the 3 courses coming up. Each course is 2 sessions of 2 hours. So you'll be getting a full 4 hours from these very experienced gentlemen. All right, well, I think we'll wrap it up there and move straight on, unless there's any final comments from yourself, Konrad, Wolfgang, around this whole thing. We'll go to our last slide and end the webinar here, I reckon. Yep. So well. There it is. There's the dates at the bottom there. Course 1, October 1st and the 8th. That's the intro. Course 2 with Modflow-OWHM, FreeWatt, Farm Process, December 3 and 10 with Wolfgang, and the last one with both Wolfgang and Konrad, comparison of Modflow versions and GUIs. Some of the questions were touching on all those 3 areas. So terrific. We'll wrap it up there. I have nothing more to say. Konrad, if your last comment, Wolfgang, last comment.
Well, thanks very much. I appreciate all participants who attended. Hopefully, you'll get something useful for you. Thanks very much, Trevor, for organizing this, and Wolfgang, of course. It has been great.
Yeah, thanks everybody.
Been terrific. Appreciated your questions, everyone. So look forward to seeing you at the courses, hopefully. Bye for now.
Okay, bye-bye.
Subscribe to this YouTube channel by clicking the subscription button. For future webinars and online short courses, please visit our website at australianwaterschool.com.au.